Sir, are we ready to go? Am I audible?
Yes, sir. Others.
Yes, sir. Am I audible?
Yeah.
Others, Vidisha this side. I think they are joining. I've just called the vice principal right now. She told she'll just check and let me know. Yeah.
Okay, ma'am. Okay, ma'am.
Yeah, because for biology they have joined, but for math, she told she'll check and let me know what had happened. Yeah.
Okay, ma'am.
Just for some 5 minutes. Yeah.
Okay, ma'am.
Yes. Thank you.
Thank you, ma'am. Hello everyone, am I audible?
Sir.
Okay, right. So let us start without wasting any time. All of you are ready?
Sir.
Good. You all revised that we discussed in the last class, yes or no? Did you revise the thing that we discussed in last class? Hmm? Did you all revise, yes or no? Okay. So what is subset? Who will define subset? Who will define subset? Nobody? A B is said to be a subset of A if every element of B is containing the every element of A. Okay, or is taken from every element of A. So last time we did till subsets, right? Everyone? Okay. Today we'll be learning about few more topics that are related to subsets and then proceeding forward, right? So there are two kinds of subset. One is called superset, and another one is called proper subset. Proper subset. So what is the difference between superset and proper subset, right? That we'll see today. Okay. So super subset, like if we have like I'll be telling you, first let me define it. If A is equal to and a subset of B, then A is superset of B. Now, if A is a subset of B, but, or I shall write it like, and A is not equals to B, then A is a proper subset of B. What does this mean? For example, if A contains elements 1, 2, 3, and 4, B contains elements 1, 2, and 3, C is that kind of subset which is copying every element of A. 1, 2, 3, and 4. You all copy your friend's assignment, right? Then what do? You try to include something new or exclude something to make it different so that the teacher does not understand that. Isn't it? You all do these things. Okay. So B is a friend of A and C is also a friend of A. What B did, B tried to copy A but did not copy everything. Did not copy everything. C is a friend of A, he knows nothing. He copied everything. Understood? So C is a superset of A because C is a subset. C is a set that is formed from the original set A. Okay, C is a set which is formed from the original set A. All the elements of C are containing all the elements of A, but it is exactly same. And when two sets are exactly same, they are said to be superset. Understood, everyone? If you have understood, put a thumbs up. Okay. Okay, good. Girls in the middle, you understood? Okay. Now B is a proper subset. B, like the elements of B are like have been copied from the elements of A, but not all of them. B is an intelligent friend. He knew that if he'll copy everything, he'll get caught. Right? So B did not copy all of the elements. He just copied three elements of it, and this is called a proper subset. And proper subset is like denoted by this sign. So A is a proper subset of B, and C. I should write it like this. B is a proper subset of A, and C is a subset and equal to A. Understood? We learned in the last class now. What are the three properties of subset? The front bench boy, you'll tell me. You know that? What are the three properties of subset? We learned in the last class. Do you have that notes? Check it and tell me then. Have you written a point? Every set is a subset of itself. Can you see that? Can you see that every set is a subset of itself? Everyone, turn up your notes. You have not revised it. Right? Do you see that? Yes or no? Put a thumbs up. Do you see that? Everyone. So you must have seen that every set is a subset of itself. What does that mean? That means that if you take all the elements from a particular set, you can get a new set. And that should be a subset because it satisfies the condition of subset. What is a subset? Subset is a new set that has been formed from the main set. Right? Whether you take one element, whether you take two elements, or whether you take all the elements. Understood? Good. Okay. Intervals were done. So today we'll start with operation on sets. Operation on sets. So what is operation on sets? This is a new topic that we'll start with. So for example, if we have a set A, 1, 2, 3, and set B, 4, 5, 6. So there is something called union of sets. Union of sets. Okay. What is a union? You make students union, we make workers union, we make like union or something. What is union? Union is combine. Okay. You have to combine everything. You have to collect everything of that particular kind. So union of sets means the combination of all the sets. Okay. The combination of all the sets. So if I say that, like if I need to define it, the union of two sets, A and B, denoted by A union B, AU, you have to write it a U, union. A union B is the set of all those elements which are either in A or in B or in both A and B. Okay, so you have to form that collection. So if I have a set A and set B like this, and I want to write A union B, that means you have to collect all the elements that are present in set A and set B. So it will be 1, 2, 3, 4, 5, 6. Understood? You have to A union B means you have to make a new set, which is a collection of all of the sets that you like collected in the union. Understood? Everyone? Good. Written? Shall we move on to the next page? Okay. Okay. So next that we have is intersection of sets. Intersection of sets. What does intersection of set means? Intersection of is there any problem? Yeah.
We need previous page, sir.
Okay, you want to go to previous page? Yeah. Written?
Sir.
Understood? If you have any doubt over any topic, you just poke me out there, okay? Otherwise, you won't be able to understand. You have from now you have to start solving questions. I'll be giving you homeworks, and you have to solve questions from your own also. So try to collect all the information, all the concepts that have been taught in the class.
Yes,
Done?
sir. Yes, sir.
Okay, good. So intersection of two sets A and B denoted by A intersection B. You have to write the opposite of U. Okay, A intersection B is the set of all elements which are common to both A and B. Now see, if we have a set A, 1, 2, 3, 4, 7. We have a set B, 1, 8, 3, 5. We have a set like this. Can you tell me what is A intersection B? What will be the elements that are contained in A intersection B? Everyone? Think and tell me. Read the statement and think and tell me. Yes, 3 will be there. And 1, 3. Very good. 1 and 3 only will be there. So that is A intersection B, right? And what is A union B here?
Four, 5, 8, 7.
Okay. So here the union will be 1, 2, 3, 4, 5, 8, and 7. You don't have to repeat 1 twice because it is getting repeated twice. Understood?
Sir.
Good. Good. So this was 2 operations, and we'll be solving much questions based on this. Now let me give you a question. Who solved this? Who solved this? Will get a chocolate from me.
Sir.
Now if set A is denoted by the set of element X, where X is equals to 3n and n belongs to Z. What is Z? Z Integers, very good. Z, okay, and we have another set P of element X such that X is equals to 4n and n belongs to Z. Okay. Let me put some more restriction there. N belongs to Z and n is less than 5. Same here. N belongs to Z, n is less than 5. Right. So you have to find A intersection B. You have to find A intersection B. Try to solve this. So chocolate question.
Sir,
Yeah,
answer. All
you're
the.
answering.
Yes, sir.
Name your name.
Nishant.
Pardon?
Nishant.
Rishant.
Yes, sir.
Okay. I cannot see you. Okay, good. Now tell me the answer.
All the multiples of 3 and 4 less than 5.
No, I want in roster form. I want in roster form.
Namaste. I will take a student B coming from. From 11C. Looking students. By Ms. Vikravita, classroom 11C. Thank you.
Roster form. I'll be giving 1 more minute. Everyone, please try. It's very easy. Okay, I'll give you a hint. I'll give you a hint. First, you decode this in roster form. First, you decode this in roster form. Then you decode this in roster form and see what are the common elements there, and then make it a set. Easy. Okay, now it's my time. Even I have to save the money for my chocolate now. So now I'll answer. See here, everyone. So first element is the A is a set of element. Okay, that is containing the elements. We have to write it in roster form. So I have to put a condition x is equals to 3n, means that if I put the n values, what values of n I can put? I can put n values from 0 to 4. Okay, from 0 to 4 I can put. Right? So what happens here is that, okay, one more condition should be there. If I'm writing like this, from 1 to 4, let me write it 1 to 4. Okay, from 1 to 4. So what is happening here? Yeah, answer will not change.
12, sir.
Only 12 it will be.
Sir, before 0 was not there, so minus 12 now.
Okay, so you put all the values from negative infinity to 5, right?
Yes, sir.
Okay, okay. Considered. Your answer is considered then. Your answer is considered then.
Chocolate,
Okay.
sir.
Chocolate. You'll get chocolate. I'll come there. I'll come there after some time, then I'll meet you. Okay, next question.
Yes, sir.
A is a set of 2 and 4. Okay, A is a set of 2 and 4. Actually, this question originally was to be written in set builder form. That's why this was a mistake. I missed it. This question was initially in set builder form. I'll ask the same question again after this. So that's what the mistake I did, that I left it. This question is in set builder form. I'll give that question after this. Now see here, question says that A is a set of 2, 4. Sorry, yeah, and B belongs to 3, 5. Okay, the set containing 3, 5. Okay, you have to find A intersection B. You have to find A intersection B. And I want that answer both in roster form plus set builder form. Roster form plus set builder form.
Sir,
Go on.
in a roster form, the answer is.
Tell me.
Sir, it is empty. Roster.
Empty set.
Yes, sir.
No. Wrong answer. Huh? Only 3. Only 3. No. 3, 4. You have to include the brackets. You have to include the brackets. I need the brackets. Tell me the brackets. Whether it is curved brackets or square brackets, whatever it is. Who answered 3, 4? Who answered 3, 4? What's your name? Pardon? Oh, Rishant. Same boy. Okay. The 3, 4, you have to like specify whether you have to include 3 or like include 4, yes or no. You are correct, partially correct. But you have to specify whether you have to include 3 or exclude 3, or you have to include 4 or exclude 4. I'm giving you 1 more minute. Think about it. Include 3 and include 4. Exclude 4. Do you agree with this? Yes or no? Put your thumbs up if yes. Who agrees with this? Nobody? Who is there? Who is raising his hand? This is the correct answer. See how we have to do these questions. See, I'll give you a kind of hint to solve these questions very easily. You all know the number line, na? You all know the number line? Okay. Now see, I'm putting, yeah, any doubt? Okay. So I'm putting the same numbers on number line. 1, 2, 3, 4, 5, and 6, right? So if we have to represent anything like this, open bracket. Okay, so not including 2, not including 4, but including all the numbers in between. That is what it means, correct? Rishant, focus here. Rishant at the back. Focus here. So open bracket 2, open bracket 4 means what? We have to include everything that is between 2 and 4 and excluding the terms 2 and 4, right? Okay, so I'll represent it like this. Open 2, open 4, and line determines that we have to include everything between that. Now, closed bracket 3 and open bracket 5 means what? Closed bracket 3. So I'll put a solid circle. That means in the second set, I have to include this. And open bracket 5 is to be represented like this. Understood? Now you have to check for A intersection B, which part are common. So from here to here, it is common, right? In both of them. Agree, everyone? Agree? So 3 is including both or not? Both of the sets are including 3, yes or no? Both of the sets are including 3. So 3 will be included. Both of the sets are including 4, yes or no? Both of the sets are including 4, yes or no? No, sir. You don't have to answer yes, sir, everything. So 4 is not included here, but 4 is included here. So I won't include 4. 4 is not common. So I'll put an open bracket there. Now, did you understand? Will you be able to solve these questions easily? Good. This is a short trick of it. Write it down, everyone. Written. Okay. Shall we move on to the next page? Shall I change the slide, everyone? Okay. I like your confidence. Now see, there is something called disjoint set. Disjoint set. Disjoint set means what? If A intersection B is 5, so A and B are disjoint sets. You can get it out from here. Are disjoint sets. Okay. So what is disjoint sets? If two sets are not having anything in common, so both of them are called disjoint sets. Got it? Now we'll see difference of sets. So let us say that A is a set containing 1, 2, 3, 4, 5. B is a set containing 1, 2, 3, 6, 7. So if I want to write A minus B, this means that I have to make a set that is containing all the elements of A, but that should not contain any element of B. So that will be just 4 and 5. Understood? Understood, everyone? Good. So we have a question here. If A is a set of X such that X belongs to N. Okay, X belongs to N. X is a factor. X is a factor of 6. Okay. And B is a set of X where X belongs to N such that X is a factor of 8. Okay, X is a factor of 8. You have to find A intersection B and A minus B. Try to solve this. For 10 answers in a class, in a chapter, then you'll get a chocolate. You need to answer 10 questions per chapter. Try to solve this. This is very easy. Write them in roster form. Get the intersection parts. And or subtract the elements of B from A, elements of A. Get me the result.
Sir,
Yeah, Prashant.
A intersection B,
How much?
1,2.
Very good.
A minus B.
A minus B.
3,6.
Pardon?
1,3,6, sir. A minus B.
No, this is wrong.
3,6.
Only 3,6.
Yes, sir.
One is common for both.
Sir.
Such a small mistake. Okay. No problem. You must have written one in both of them. I think this is by mistake you have said, isn't it?
What, sir?
You must have written one in both of the factors. This is by mistake you must have said this, right?
Sir.
So what is A set? What are the factors of 6?
1, 2.
It is 1, 3, and 6, right? What are the factors of 8? It is 1, 2, 4,
8.
and 8. So if you find A intersection B, what are common both of them? So it is 1 and 2 that are common both of them. Write something that is not there in B. That should be there in A, but if it is there in B, you have to exclude that. So what is there in A and that is not there in B? Okay, so 1 is there in A and 1 is there in B, but the B part you have to exclude. So this I cannot write, 2 I cannot write. Okay, so 3 is there in A, that is neither present, that is not present in B, and 6 is there in A, that is not present in B. So these two elements I'll be writing in A minus B. Got it? Okay. I need every one of you to answer. Prashant has got. Write it down, everyone. Shall we move on to the next page? Right. So now we'll be studying on laws of operation on sets. So we'll be studying about laws of operations on sets. Okay. So what are the laws of operations on sets? First is idempotent laws. Idempotent laws. What is this law? This law says that if you are taking a union of the same set, you'll get the same set. Yeah. So you get the same set. If you take the union of two same set, you get the same set, right? This is one of them. Or you take the intersection of the same set, you get the same set. Isn't it? Easy. Second law. That is identity laws. You know what is additive identity or multiplicative identity? Anyone know that? Additive identity and multiplicative identity we studied in class 8 and 9. Similarly, we have identity law in the sets also. Okay, so you have to get the same identity. If you're taking a set, you have to add, subtract, multiply, divide, something like that, and you have to get the same identity. So if I'm taking the union of a phi, that is null matrix, null with some set of set A, element containing some set A. Okay, so what will I get? If I have to make a union of nothing and something, so I'll get something, isn't it? Let us say A contains 1, 2, 3. 1, 2, 3 union phi. So you have to include phi there, and phi is disguised. Phi is not to be written, even if it is included, isn't it? So you get the same set A. Okay. Now, A intersection universal set. U is called universal set. That contains all of the elements of the universe. So you'll get A. Because from all of the elements of the universe, you have to find common which is there with A. A. Understood? Understood, everyone? Put a thumbs up. Okay. Okay. Next. Third, which is there, is commutative laws. Commutative laws. Commutative law says that if A union B is there, so you can write the same thing as B union of A. Right? If I'm taking an example, A is 1, 2, 3, and B is 4, 5, 6. What is A union B? 1, 2, 3, 4, 5, 6. Agree? And what is B union A? You write the same matrix. 4, 5, 6. Isn't it? So it doesn't matter if you are doing A union B or you're doing B union A. Both will give you the same result. Right? Same thing as A intersection B or is equals to B intersection of A. Right? Understood? We can prove it also. How we can prove it? Let's see. Let's prove the first one. Let us say that X is an element that belongs to A union B. X is an element which belongs to A union B. That means X belongs to A, and union means or X belongs to B. A union B means like if we have taken an element 3, so either 3 should belongs to A or 3 should belongs to B. Either of them it should be true. So that's why I'm writing or, not and. For union we write or, and for intersection we write and. Like and means what? It should be there in both of the elements. Then only we take the intersection. So X belongs to A or X belongs to B. Right? And we can write conversely also. Conversely, or we can write it like this. X belongs to B or X belongs to A. How does it matter if you write in what order? Isn't it? It doesn't matter. So from here, we can conclude that X belongs to A union B. Sorry, from here, it was B union B. First, you have to write B. B union B. Okay. Similarly, we can prove this one. Understood? Now, next thing. This was commutative property. Next, we have associative. Which one? Which number was that? It was 3. Associative property. Associative property. So what does associative property says that? Says that A union B, you can associate in any order. That is what it says. Is A union B union C. Or A intersection B intersection C is A intersection B intersection C. Understood? Okay. And we'll prove one of them. We can prove one of them. So similarly, we can do the next one. So if we say that X belongs to A union B, to A union, sorry, not this one. Yeah. A union B union C. Now this one. Yeah. A union B union C. So that means X belongs to A union B belongs to C. Understood? If you break this belongs to A or X belongs to B in bracket or X belongs to C. Okay. But if I change the bracket, nothing will change. It can be written as X belongs to A or X belongs to B or X belongs to C. Will anything change? Nothing will change. So X, I can now write it as X belongs to A union B union C. Understood? So similarly, you can do this one. They may ask you in school exams, this is important, but this result is important for like competitive exams. Here in school, they may ask, depends on them. Like derive this thing if it is possible or not. Okay. Written, shall we move on to the next page? Or I can write it like here. Next is distributive law. These are quite a memorizing thing. Distributive laws. What are distributive laws? All these things you have already studied itself in several other topics of maths. So distributive law, A union B intersection C is equals to A union B intersection A union C. Okay. Or second one, if you write that A intersection B union C is equals to A intersection B union A intersection C. It is kind of multiplication, right? Opening the bracket as we used to do. Okay. Written, everyone? Good, good, good. So we can prove any one of them. So if we say that X belongs to A union B intersection C, okay. Or, oh, shall we move on? Okay. Take your time. Okay, at the back it is done. In the front. Okay, okay. So if we write something like this, so I can write it as X belongs to A or X belongs to B intersection C. So I can write it like X belongs to A or X belongs to B and X belongs to C. Right? X belongs to C. So now what I can do, I can write it like this. I have to first write it, I can write it like this. X belongs to A or X belongs to B and X belongs to A or X belongs to C. I just try to multiply this with all these bracket terms. That's easy. So now I can write it instead of union, A union B, and instead of and you have to put intersection. Yes or no? Understood, everyone? We can prove it in one more way. Now we can take one more term. Let us say y belongs to Y belongs to, if we go conversely, going conversely, so we are taking, let Y be an arbitrary element of A union B intersection A union C. So what we are doing, we are taking an element of this particular set, right? And then we'll prove that this is same as this set. Okay, like that will go. So Y should belongs to A union B intersection A union C, right? From there we can say that Y belongs to A union B, and instead of intersection we can write and. Y belongs to A union C. Now if you change that, so Y belongs to A or Y belongs to B, and Y belongs to A or Y belongs to C. Okay, from there what we can get, from there Y belongs to A is common, so I can write it like Y belongs to A, Y belongs to A, or Y belongs to B and Y belongs to C. So Y belongs to A union B intersection C. Okay, so all conversely also we reach the same point. Agree or not? If we went on in the reverse manner, we reach the same point from where we started. See, from where we started, we reach the same point. So that means it is true. These derivations are not important. Still, I'm letting you know so that you can get to depth knowledge of it. Maybe they can ask in school exams, but not for competitive. So if Y belongs to this and Y belongs to this, that means this is a subset equal to this. And hence that is true. Written, everyone? For union, we write or, for intersection, we write and. Always remember, you can easily derive it. No, new concept is used to derive it. Okay, shall we move on? Okay. Front benchers. Right. So we can say that if Y is there in both of the terms, we can say that A union B intersection A union C is a subset equal to A union B intersection C. Okay, A union B intersection C. If it is, you can say that it is equal to or same thing. So you can multiply it like this. Like generally, if I used to write it 4 times 5 plus 6 is what? So you should have done it now. 4 into 5 plus 4 into 6. You do it? Yes or no? What do you do? You multiply with this, you put multiply with this. Same thing you have to do here. You multiply with this, you put the middle sign, you multiply with this. Same thing you'll be doing here. Isn't it? Understood? Yes or no? So last we have is a De Morgan's law. What number it is?
Number 6.
6. Okay. De Morgan's law. Okay. De Morgan's law says that A union B dash is equals to A dash intersection B dash. Okay. And A intersection B whole dash is equals to A dash union B dash. Now what is this A dash or B dash? See, A dash means all those elements which are not there in A. If I used to write A means what? That all those elements.
We want to know how to put this in this verse.
Okay. So A contains all those elements which are there in A. A dash contains all those elements which are not there in A. Elements not present in A. Okay. So similarly, A union B dash means what? A first what you have to do? You have to do A union B and then you have to take the complement. That means if A is there, 1, 2, 3, 4, and B is there, 2, 3, 5. So what will be A intersection B? So A intersection B will be 2 and 3. And what is A intersection B complement? That means not A intersection B. That is not common to both of them. So that will be 1, 4, and 5. Understood? Yes or no? Did you understand it? Yes or no? This phi sign or this complement signs means those elements you have to like not follow this rule. If they're asking A intersection B complement, that means you have to do A intersection B and you have to take the opposite of that. So A intersection B in this particular case was giving me 2 and 3, and now I have to take complement. That means not 2 and 3. Apart from this, everything. Now understood? So you write till here. We'll stop here and we'll complete the chapter in the next class and we'll solve some questions. So you solve all those questions till where we have covered. So we have covered till the laws, right? You solve all the questions that are possible that can be made, and that is there in the different books. You should follow at least 2-3 books. Okay. Try to solve till here. Any doubts we'll discuss in the next class. I need doubts from your side. Any doubt in this class that we discussed today?
No, sir.
Everyone? Did you like the session? Okay, okay. Try to solve questions, more and more questions, then it will get clear to you. All these concepts will be cleared only if you solve questions, right? And discuss. Solve and discuss. You will understand everything. And this will become easy. Okay? So we'll meet in the next class. Bye. Okay. Bye. Thank you.